Hey guys, and welcome to the first video in our linear algebra series. In this video, we will see how we can visualize 2D and 3D vectors in Matlab. So, first, let me see. Let me write the command. I have already written a command to take an input array from the user. You can use the input function for that. There's no need for any other additional inputs. In the function command. So if I run this, if I can, input any, say, any matrix or vector or in general any array using the input function like this, just remember to put the square brackets and the semicolons in their right place. Um, so first, let's try plotting this with the plot function in Matlab. We had already seen the syntax and everything of plot function. Usually, when we plot vectors on paper by hand, we start from the base of the vector. We mark the coordinates of the base of the vector, then the coordinates of the head of the vector. Then we draw a line connecting these 2 points and put an arrowhead to at the head of the vector to indicate the direction of the vector. Now we are going to do somewhat the same thing here. We are going to draw a line connecting the head and the base of the vectors. So here I am assuming the base of all vectors we are drawing to be at the origin of the coordinate system. Now you can change this if the vector starts at some other point. Now plot origin of one, vec 2 of one, then origin of 2, then vec 2 of 2, and let's run this here. So here when I input a vector, say 5 minus 2, and run this. So here I get so this is how you plot 2D vectors using plot function. But we have a problem here. If another person comes and sees this figure, he is not able to tell the direction of the vector. So we don't know whether this vector is it going from this point to this point or from this point here to this point. So to so that is the drawback of the plot function in MATLAB. That is the drawback while plotting vectors using the plot function in MATLAB. So to solve this, we have the quiver function, which draws these vectors with arrowheads to indicate their direction. So let me just, clear the figure. Uh, Okay. Now, the quiver function. Now, the word quiver has two meanings. One is to tremble or to shiver, and the other meaning is that it's the name of an archer's case for holding arrows. You guys might have seen these long cylindrical thing which archers put their arrows in. So that is called quiver, and the quiver function in MATLAB is used to create a 2D field of arrows, which is often used to visualize vector fields. So we usually give four inputs to this function, as you can see here: x, y, u, and v. Now, x, y, these are the x and y coordinates of the bases of the arrows, and u, v, these are the x and y components of the vectors. They define the direction and magnitude of arrow. So let's see here what that means. So let me just comment the first line out, since we no longer need, we have already entered our vector. So quiver same 0 0. So this is the base of the arrows. Then we need the x component. X component means the number of units, you know, the arrow should move, the vector should move in, the vector should travel in the x direction. So let that be, so that is vec of vec 2 of 1. And then the y component, the number of units the vector should travel in the y direction. So when I run this code here, see, now we know the direction. We can, tell the direction of the vector by seeing the figure. So if you look here, let me open this in the figure window. If you look here, the vector, it starts at 0 0, and it should have terminated at 5 minus 2, but it's terminating at 4.5 minus 1.8. So why did this happen? Now MATLAB by default, the quiver function in MATLAB scales the arrow lengths so that they do not overlap. Now this is called auto scaling, and this property controls whether the arrows are automatically scaled to avoid overlapping. So this is done. So if I plot another arrow in the same figure, this is done so to, avoid overlapping of both vectors or both arrows in the figure. Now, this feature is turned on by default in MATLAB. Now, we can turn it off using the keyword auto scale. Then, oh, now when I run this again, now the vector, it gets terminated at 5 minus 2. So now one thing to note while using the quiver function is that x, the first two inputs are the basis of the base coordinates of the vector, and the next two inputs, these are not these are not the coordinates of the head of the vector, but the number of units the vector should move in x and y directions. So if you see this figure here, so the line, the vector, it starts at point 0 0, then it moves 5 units in the x direction, and then minus 2 units in the y direction, and it terminates here. So this is how the quiver function actually works. So if I change the base of the function of the vector to say some point 1 1 instead of 0 0. Now if you think that this input here will create a vector that starts at point 1 1 and ends at point 5 minus 2, then you are wrong, since It of course starts at 1 1, but then it travels 5 units in the x direction and minus 2 units in the y direction. So the vector terminates at the point 6 minus 1. So if you want the vector to, terminate at this point, you can just subtract the uh, origin, like the coordinates of the origin coordinates of the from the coordinates of the origin from the x and y components of the vector. So here again, if you look, this starts at 1 1 and ends at 5 minus 2. So these the third and fourth input, they are not the coordinates of the head of the vector, but they are the x and y components of the vector. They determine how much units the vector should move in x direction and y direction from the origin. Now we can also add labels to vectors in MATLAB. For example, if I prompt same text. Now we will give the first two inputs determine the position of the text to be displayed. So if I want my text to be displayed at the point 0 0, just type 0 0. Then the third argument is a cell array of strings containing the label. So uh, the vector. Now when I run this here again, so here you can see this time I have labeled my vector here. So this is how you label vectors if you want. And you can also customize the appearance of this vector, just like we had done in case of plot functions, the plot lines. While dealing with the plot function and scatter function, you can change the size of the arrowhead if you want. For example, we have the keyword max head size, and if you put some number, say 2, this changes the size of the arrowhead here. So when I put 2, this increases the size of the arrowhead, and you can decrease this also if you want. So if I type 0.0009 and enter, so we get a smaller arrowhead. So you can also, change the style of this vector line. You can change the line width if you want by adding extra annotations to this quiver function over here. Now this is basically how you plot 2D vectors in MATLAB, but you can also make this look a bit more aesthetic if you want. So now, if you guys don't know, almost all plotting functions in MATLAB return something called a handle. Now, a handle is a kind of address to identify all graphic objects. For example, it's like a variable that stores the information about these graphic objects that we have created in MATLAB. So, if I type, say, A is equal to GCA. By the way, GCA stands for get current access. It's a function that returns the handle to the current access in the current figure. So if I select this and run this in the command window, here you can see that the properties of the access gets stored here in the command window. So now if you want to see so if you just type A in the command window, you get some properties of the axis, and if you want to see all properties, you can use the get function. So get of a will uh, will display all the properties related to the axis of the axis or related to the axis stored in A. Now, if you want, say, if you are plotting some other curve and you want, um, the properties of that line. For example, see, if I am prompting something like this, 3 comma 4. Now, this here, the plot function, this plots this figure over here, and it stores the details related to the figure in this handle called HAN. So when I hit enter, now we get the this plot is being created, and we have the hand handle with which stores the properties of the line which we have plotted. So this is how you store whole properties of graphic objects in MATLAB. So let me just clear HAN from the workspace. So now let's try to manipulate the axis of this graph over here to make this look a bit more cool. So if I type a dot now you can I can change the details of these axes using the dot operator here, or there is a function called set which can be used to do the same. So if I type a dot x-axis uh, location, so and if I type origin, so this shifts the x-axis to the origin, and a dot y-axis location to the origin, and I can change the y limit. So let this be say minus 6 6. So minus 6 and 6, and I can also change the x limit, and let's turn on the grid to make this more nice. And when I uh, run this code here, so we get a more nicer, a bit more beautiful plot here. So here you can if you zoom in, you can see that it terminates at 5 minus 2. Now if you want to change how the grid looks, you can also change how the grid looks. So for example, if I type change grid minor, it now this time this will show minor grids, and if I just type on, the size of the grid lines changes. So this is how you change grid lines in MATLAB. So this is how you plot 2D vectors, and if you want, you make the you know figure nice by manipulating the details of the axis. Now, so let's look at how we can manipulate 3D vectors in MATLAB. So we have the quiver tree function to plot vectors in 3D. So first let's write some vector in 3D. For example, vector is equal to say 3 minus 4 and 5. And let's use the quiver tree function to plot this. So the first three inputs quiver tree. So here we have 3 plus 3 6 inputs. Now the first three inputs obviously are the um, base of the vectors. Now then the next three inputs are um, the x, y, and z components of these vectors. And let's switch off the auto scale option in MATLAB. Then okay, off. And let's run this here. So here you can see this created a vector which starts from 0, 0, 0, and terminates at the point 5, uh, 3, 5 minus 3 minus 4 and 5. So we can label the x, y, and z axis for much more better readability. So x label x, then we have the y label y, then the set label set, and let's run this again. So here you can see it moves 3 in the x direction, it moves minus 4 in the y direction, and it moves 5 units in the z direction. Now like we had done in the case of 2D vectors, we can also manipulate the axis. We can plot the axis of 3D vectors. So let me use the hold on function to plot the axis of these vectors. So hold on, and here defining. So this is the first component of I am defining a handle edge, and using handle edge I am going to plot the axis. So first let me set the x, y, and set limits of the graph. So minus 6 6. So and set okay, and let's draw the axis. Let's plot the axis in this 3D graph over here. So mm, x limit, then 0 0, then comma 0 0, and then so here I am plotting dashed black lines. So similarly, let's plot. I have now this. The first command was to plot the x-axis. Now similarly, let's plot the y and z-axis. So Control plus C, Control V, and let's move this to here and Control plus C. Now let's plot. Write the command to plot the y-axis. Sorry, the z-axis. So okay. Now let's um, run this over here. So before that, let me type the hold of function and let's try to run this here. So here you can see these dotted lines over here. They represent the x, y, and z axis, and this over here. This is our vector. So this is how you plot 3D functions in 3D vectors in Matlab. So we could have stopped here, but manipulating the values of x-axis and x, y, and z-axis and plotting these axes, they add beauty to your figure. So this is how you plot 2D and 3D vectors using quiver and quiver tree functions in MATLAB. So that was all in this video. Thanks for watching. Bye.